intermolecular forces and physical properties. Now, today we are going to see how these intermolecular forces, which we just discussed, the VDWs and hydrogen bonds, they affect the physical properties of these compounds, right? Again, I would like to remind you that we are talking about which compounds? Covalent compounds, which have the covalent bonds. And what is the structure? Simple molecular structure. Okay, exists in the form of tiny molecules. Now, their physical properties, the melting and boiling points, they entirely depend on the intermolecular forces. So please write down okay, covalent bonds, covalent compounds with simple molecular structure. With simple molecular structure, properties depend on the strength of intermolecular forces present between molecules. Like properties. लोग जूम आ रही है ओके ठीक सब नहीं है नेट नहीं चल रहा पीछे रह जाएंगे Okay, please pay attention. Okay, please pay attention. So physical properties like melting point, boiling point, etc. depend on the strength of intermolecular forces. For example, the compounds having hydrogen bonds as intermolecular forces, the compounds having hydrogen bonds as intermolecular forces have significantly higher melting and boiling points. Why? Because this is the strongest intermolecular force, as it is strongest intermolecular force. ये सबसे strongest intermolecular force. Hence, the compounds having this, for example, look. For example, look at this. For instance, look at this. Water and H2S. These two are the similar compounds. Water has intermolecular force, hydrogen bond. This has the intermolecular force VDW. Water boiling point is what? 100. The H2S boiling point is minus 45, right? Which tells you a huge difference. Otherwise, both these molecules are exactly the same, right? They have the same shape, same geometry, sulfur, oxygen, they are in the same group. Everything is the same, right? But difference in their intermolecular force is due to what? The hydrogen bond. Similarly, if I look at this hydrogen fluoride, look, if you look at the hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide, look at these two. So hydrogen fluoride has a highest boiling point. Okay, here. On the other hand, this is HCl, this is HBr, this is HI. Why this has a significantly higher boiling point than HCl? Yes, its intermolecular force is what? Hydrogen bond. And their intermolecular forces are what? VDWs. But still you can see a slight increase in their boiling points, even though their forces of attractions are VDWs. You know the reason. VDW strength only depends on the what? Number of electrons. So here the change is, okay. So when the number of electrons increase in a molecule, the strength of VDW is increasing. That makes this difference. Okay. Otherwise, hydrogen fluoride has the highest because of the hydrogen bond as intermolecular force. Similarly, I give you the more example. The first thing the examiner is going to ask you is this. Okay, why they have a different or significantly higher melting and boiling point is because of hydrogen bonds, right? Otherwise, all these compounds, when they have a higher melting and boiling points, their intermolecular forces are relatively stronger. So whenever they ask you why, for example, this compound has a higher melting point than this or boiling point than this, you will refer to the intermolecular forces. One more thing which you have to write is the compounds with hydrogen bonds as intermolecular force. What they have higher surface tension, right? So please write down the compounds with hydrogen bond as intermolecular force have relatively higher surface tension. I'm not going into the detail of this. Just want to say that these are the two liquids. One is water. One is, let's say, petrol. Surface tension means the molecules, the force of attraction between the molecules. Okay. This is. Okay. And if this is the petrol, the force of attraction between them is weak, which is VDW. Here is the hydrogen bond. So it's a very stronger force here. So relatively higher surface tension is in this case. Okay. The surface tension. The surface tension means the force between the molecules of water on the surface is stronger than the force of friction between the molecules of water. Because the intermolecular force of water is hydrogen bond, which is stronger force than the petrol, which is the weaker VDW. Okay, just this information you need. Secondly, one more thing, the anomalous behavior of water. Is again due to hydrogen bonds. What is the anomalous behavior of water? You know, water is the only liquid which density is what? The solid water, the ice density is less than liquid water. That's why the ice floats on the surface of water. Otherwise, when the liquid freeze, this density increases, right? So, लिख लीजिए, ice is less dense than water due to ice is less dense than water due to hydrogen bonds. And because of this anomalous behavior, what happens? The water freezing pattern is different. The water freezes from the top first and then bottom. That's why all those polar regions where the oceans and the water freeze, the aquatic life survives. Why it survives, the fish and all that? Because the top surface turns into solid, but the underneath water that remains there. So therefore, the fish and all those aquatic animals, organisms, they can survive in those. And this is again due to this anomalous behavior of water due to the hydrogen bonds, right? I'm not going to explain this, but this is actually happening because in the liquid, when they come close together, look, when you freeze them, they have to come close together and density should go up. But when they close together, then there is a point where due to the hydrogen bonds, they can't go further close to each other, and that's why the density of ice is not less than water. Okay, is less than water, not more than water. Okay, so this is how the anomalous behavior of water. So that they ask you these three types of questions: that why the water has anomalous behavior, it is due to the hydrogen bond. Why water higher surface tension, due to the hydrogen bond. Why water has a higher melting and boiling point than other liquids, is due to the hydrogen bonds, right? Okay, now that's end of the intermolecular forces and their effect on the physical properties of these compounds, right? Now moving on. Now I'm going to compare all these three types of bonding, right? And we're going to wind up this chapter here. So what we have, these types of bonding, what you have to do, you have to use a full page. So I'm going to put them in comparison here. You have to use a full page like this. Here, let's say this is the melting point increasing upward. Okay, here is the melting point that goes up. So if you look at the bonding and structure, there are ionic bond, there is a covalent bond with two structures, simple molecular and macromolecular, and there is another bond known as metals, metallic bond. Now I'm going to compare all of them together here. For example, the compounds which have the covalent bond and simple molecular structure, they are at the lowest point. Mean lowest point, they have the low melting and boiling point. So please, at the bottom you write low melting and boiling points. What are these compounds? All out of all those compounds, the low melting and boiling points kiska hoga? The compounds which have covalent bond and simple molecular. And now we got to know why do they have low melting and boiling points? We just learned it, that their melting boiling point depends on their strength of intermolecular, and intermolecular forces themselves are very weak forces, right? So please write down wajah kya hai. There are weak intermolecular forces which do not need much energy to overcome, hence low melting point and boiling point. And low melting boiling point means, I'm just going to give you a rough idea. Just think about 100 degree or less. So low melting boiling का मतलब समझ आना चाहिए ना. What is the meaning of low melting and boiling? 100 degree and less. So whenever they ask you that this compound has a low melting boiling point, the compound you may not have ever heard about it, like SiCl4. You say we never heard about it, but they say low melting and boiling point. You have to copy this thing. It has a covalent bond, simple molecular structure, weak intermolecular forces. Now you have to tell the forces, which are the forces. Weak VDWs, which do not need much energy to overcome. On the other hand, now above this, Yeah, you have to now mention which forces. Yes, yes, you can. Now, above this is high melting boiling point. Like above, let's say from 100 to, I believe, 600. Again, I'm saying I'm just giving you a food for thought. If they're not the exact values, they're not the exact values, right? They're just food for thought, right? So 100 to 600, for example, right? These are the compounds which have the melting boiling point in this range. They are the compounds which have metallic bond, and they are the metals, and their structure is GML. What is GML? Giant metallic lattice. Giant metallic lattice. GML mean giant metallic lattice. This is giant metallic lattice. Okay, now what about this? These compounds, please write down, they have, why they have high melting point? Because they have strong electrostatic forces of attraction. Yes. Now you have to mention that they don't have intermolecular forces. They have strong electrostatic forces of attraction. Where? Between cations and delocalized. Yes, between delocalized electrons and metal ions or atoms. Okay? And if you remember, they are like this. Here is the 1, 2, 3, 1, 2, 3, 1, 2, 3. So you have to draw a structure like this. Here, positive ions. And what is in between? Sea of electrons like this. They are actually the electrons which have become free from their valence shells. Right? They have not lost them, they are free. Free mean this atom's electron moves from here, 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 and then comes back. Then it starts coming backward. So it keeps moving all the way. So they are known as delocalized or free moving electrons. And what is this? This is what the lattice of what? Positive ions. What is this? Lattice of, yes, lattice of positive ions. And what is this force of attraction? Electrostatic force of attraction between these metal ions and the sea of electron. This force is electrostatic force of attraction. As this force is strong, needs good amount of energy to break. That's why the metals have a reasonably good and high melting and boiling point. Okay. So although they are not very high, but still high. Okay. So the structure I told you, giant metallic lattice. Giant metallic lattice consists of lattice of positive ions and sea of electrons. And then they have strong electrostatic forces. Above this, again, high melting and boiling point. What is this? The compounds with high melting and boiling point are the ones which has ionic bond and giant ionic lattice. Okay. The next one is, let's say, from 600 to this range which I'm giving you is a flexible. Okay. This is not the solid range. Okay. I'm just giving you a food for thought. When we say high melting point, what we mean about it. So 600 to, let's say, 2500 around. Even aluminum oxide has 2800, but roughly in this area they have the melting point. What type of bonds they have? Ionic bond, and the structure is giant ionic lattice. Again, you have to describe why. What is the reason? The reason is there are, again, strong what? Electrostatic Forces of attractions. Strong electrostatic forces of attractions between the ions which need a lot of energy to break. We did this initially, the sodium chloride, cubic lattice, and all that. Hence, very high melting point. High melting point. And there is on the top, very high. There is a group of compound which has the melting point even higher than compounds. Yes, they have the covalent bond and the structure is giant macromolecular structure. Very high melting point and boiling point. They have the covalent bond and MMS mean macromolecular structure, right? And they are the ones that goes from, let's say, 2500 to above. Okay? There is a network of strong covalent bonds Why they have a very high energy? Because they don't have the weak intermolecular forces. They don't have electrostatic forces. Even stronger than that is the strong network of strong covalent bonds, which needs a lot of energy to break. Hence, very high melting boiling point. For example, if you remember, look at this. One example is diamond. One example is silicon dioxide. You remember? Look, it's like this. There is no intermolecular force and there is no just one bond. There is a network of strong covalent bonds. Okay? Like this. There's a network of strong covalent bonds like this. Again, silicon bonds with 4 oxygen and then again oxygen bonds with the silicon. There is a network of strong covalent bonds. Okay? Right? So when they have to melt, they have to break, look, these forces. And there is not 1, 2, 3 covalent bond. What is this? Network of strong covalent bond, which needs a lot of energy. Here again, there's an, even in the graphite, there's a network of strong covalent bond along with the intermolecular forces layers. So that's why. So this is how you compare the all 3 types of bonds. And this is how you, for example, they ask you a question like this. For example, look, now let me put a question here, keeping this in front. Okay, if I ask you a question, sodium chloride, please you can write it down. Please write down. Sodium chloride has a high melting point. NaCl has high melting point, and SiCl4 low melting point. Describe in terms of bonding and structure why. Describe in terms of bonding and structure why. There are 4 marks or 3 marks question like this. Describe in detail. Describe in terms of bonding and structure. Please give it a shot. Why? Just 1 minute. Everyone, please write down the answer. Write down the answer, please. Anyone?
NaCl has a giant ionic lattice and has ionic bond between them, so has a higher melting point. But on the other hand,
No. Yeah, he's already telling you that they have high melting point. Why do they have high melting point? You have to describe this.
between them, higher stronger. Where SiCl4 has a weak intermolecular, which is.
What did you write?
NaCl has ionic bonds with a giant ionic lattice maintaining strong electrostatic forces of attraction between them, while SiCl4 has covalent bond with simple molecular structures, so less energy.
No, but weak intermolecular forces. You need to mention the forces of attraction which are going to break. Weak intermolecular forces. So answer is NiCl, ionic bond, giant ionic lattice, strong electrostatic forces. So these three keywords are give you the marks. On the other hand, SiCl4, covalent bond, simple molecular structure, weak intermolecular forces. These three keywords gonna give you the mark. That's why the difference in the melting and boiling point. What about this? Why melting point of SiO2 is much higher than melting point of SO3? Again, you have to write it. You have to write it. 2 marks. You have to just justify why they need high energy.
So silicon dioxide has a giant structure as it formed a covalent bond, but what's the full form of MMS?
Macromolecular structure.
Macromolecular structure.
SiO2 has a covalent bond.
SiO2 has a network of strong covalent.
Strong covalent, right? It has a covalent bond, macromolecular structure. So therefore, network of strong covalent bond. So this is the keyword which needs a lot of
energy to break them.
Break. So when there is a network of strong covalent bonds, so examiners understand that that needs a lot of energy to break. On the other hand, SO3 has a covalent bond. Simple, but first you need to describe the structure now. When there is a simple molecular structure, then there is a weak interest. So SO3 has what?
Simple molecular structure.
Weak intermolecular forces, which do not much energy to break. When you say weak intermolecular forces, when you say now you have to, sorry, one more thing. Now you have to describe these forces because we know the forces. So we have to describe the name. What is sulfur trioxide forces? Hydrogen bond or VTWs? Yeah, so you have to write that there are weak forces, VTWs and sulfur trioxide, which do not need much energy to break. That's why sulfur trioxide's melting point is lower. What about these two, MgO and Na2O? Why the melting point of MgO is higher than Na2O? Now in this case, you see both of them as ionic bond and giant ionic lattice. But still magnesium oxide has a higher, so it means its electrostatic forces of attractions are stronger, and they are stronger because of their charges. Magnesium is +2 -2, and this is +1 -2. So here you are going to mention that both of them has ionic bond and giant ionic lattice. strong electrostatic forces, but magnesium's oxide electrostatic forces after actions are relatively stronger because of higher charge. No, that doesn't make +1. There is one ion, so that's the number of moles. But the ratio is different, but one positive is attracting two negative. That's what we have to see. Next, look at this. Now, why SiCl4 has higher than PCl3? Give it a shot. Why SiCl4 has higher than PCl3?
Number of electrons.
Both of them has which bondings? Whenever they ask you the physical properties, you just refer to the bonding and structure. And why SiCl4 has what? Covalent bond and simple molecular structure. PCl has a covalent bond and simple molecular structure. Both of them has weak intermolecular forces and no hydrogen bond, so both of them has van der Waals forces. Then why SiCl4 has higher? Why its VDWs are stronger? Yeah, so one factor which we discussed, that was the number of electrons. So when they say both of them are VDWs, but one of them needs more energy to break or higher melting point, means the VDWs contains more number of electrons, right? So we'll continue this. We'll just a few questions and then we'll start organic in the next class, right? Thank you very much.